Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. Happy Friday, space fans. We've got a great one for you today.
We do 6 stories, and honestly, this is one of the more varied lineups we've had in a while. We've got planetary defense, a cosmic laser from halfway across the universe, a solar superstorm hitting Mars, a SpaceX rocket polluting the atmosphere on its way down,
A mystery satellite launch from the other side of the world, and my personal favorite, scientists trying to grow chickpeas on the moon.
Moon hummus, Avery. That's where we're headed.
Moon hummus. Let's go.
Okay, first up, great news for anyone who's been losing sleep over asteroid 2024 YR4. NASA has now officially ruled out any chance of it hitting the moon in 2032.
Right, so let's quickly recap the story for anyone who hasn't been following it. This asteroid was discovered back in December 2024, and for a while it was genuinely alarming. It briefly became the most dangerous asteroid identified in the last 20 years, with a small but very real chance it could hit Earth.
That Earth impact risk was ruled out fairly quickly. But when the asteroid faded from view last year, astronomers were left with something almost as intriguing: a lingering 4% chance it could strike the moon on December 22nd, 2032.
4% sounds small, but in asteroid terms, that's enormous. We're talking about a 60-meter rock, roughly the same size as what caused the Tunguska event in 1908, or what dug out Meteor Crater in Arizona. If it hit the near side of the moon, it would have created a crater about a kilometer wide and put on the most spectacular light show humanity has ever seen from Earth.
So everyone's been watching very closely. The problem was, by spring last year, the asteroid had drifted so far away it was invisible to pretty much every telescope on Earth and in space, with one exception.
The James Webb Space Telescope, which pushed itself to its very limit to catch this thing. A team led by the Johns Hopkins Applied Physics Laboratory used Webb's near-infrared camera in 2 observation windows, in February, the 18th, and the 26th, to track down this incredibly faint speck against the background of stars.
And the result was clear. The new measurements allowed scientists to map 2024 YR4's trajectory with enough precision to rule out a lunar collision. Instead of hitting the moon, it's going to pass at a distance of about 13,200 miles from the lunar surface, which is, yes, closer than some satellites orbit Earth, but it's a miss.
13,200 miles is basically next door in astronomical terms, but next door is still a miss. The moon is safe, Earth is safe, and 2024 YR4 is just gonna keep trucking.
NASA says they'll observe it again when it swings back near Earth in 2028. So the story isn't quite over, but for now, the threat is officially off the table.
Good news to kick off the show. What's next?
Okay, story 2. This one comes out of South Africa, and it involves what scientists are describing as a cosmic laser. And I mean that almost literally.
Tell me more. Lasers in space sounds like something I need in my life.
So astronomers using the Meerkat radio telescope in the Karoo Desert have detected the most distant hydroxyl megamaser ever found. It's located in a violently merging galaxy 4 than 8 billion light years away, and the signal is so powerful that researchers are actually calling it a gigamaser rather than a megamaser.
Okay, let's break this down for people. What exactly is a hydroxyl megamaser?
Right. So on Earth, a laser works by exciting atoms or molecules until they release light in a very tight, amplified beam. The same basic physics can happen in space, but instead of visible light, it happens at radio wavelengths. Hydroxyl molecules, that's one hydrogen, one oxygen, in massive gas clouds can be excited by the energy of colliding galaxies and amplify radio waves in exactly the same way. When the signal is extraordinarily bright, it's called a megamaser.
So it's a natural radio laser powered by 2 galaxies smashing into each other.
Exactly. And the one Meerkat found, cataloged as HATLAS J142935.3-002836, is the most distant and luminous example ever detected. We're seeing it as it existed when the universe was less than half its current age.
And you said there was a gravitational lens involved as well.
Yes, this is the really lovely part of the story. On its 8 billion year journey to Earth, the radio signal happened to pass directly behind another completely unrelated galaxy sitting between us and the source. That foreground galaxy's gravity bent and warped space around it, acting like a natural magnifying glass and amplifying the signal even further before it reached Meerkat. So we have a natural space laser being focused by a natural gravitational telescope.
That is genuinely delightful. The universe just handed astronomers a cosmic gift.
The lead researcher, Dr. Thado Monamela from the University of Pretoria, described it beautifully. He said they were seeing the radio equivalent of a laser halfway across the universe, and that it was a wonderfully serendipitous discovery.
And the bigger picture here is that Meerkat is a precursor to the Square Kilometer Array, the SKA, which is going to be even more powerful. So this is just a start of what's possible.
Exactly. Bonamela's team wants to find hundreds, even thousands of these objects, and when the SKA comes online, that's going to become a real possibility.
Incredible. All right, story 3.
And a bit of recent space history.
Story 3 takes us back to May 2024 and to Mars. You might remember that in May 2024, Earth was hit by the biggest solar storm recorded in over 20 years. Spectacular auroras were seen as far south as Mexico.
I remember it well. Half the world was posting aurora photos.
Right, but that same storm also slammed into Mars. And thanks to ESA's 2 Mars orbiters, Mars Express and ExoMars Trace Gas Orbital, we now know in unprecedented detail what that actually looked like. A new paper published today in Nature Communications reveals the full picture.
So what happened to Mars?
In short, Mars got absolutely hammered. The storm sent fast-moving, energetic, magnetized plasma and X-rays flooding towards the red planet. When this barrage hit Mars's upper atmosphere, it stripped electrons from neutral atoms, causing 2 distinct layers of the atmosphere to fill up with charged particles at altitudes of around 110 and 130 kilometers.
How much of an effect are we talking?
The electron density in those layers surged by 45% in one and a whopping 278% in the other. Lead author Jacob Parrott from ESA described it as the biggest response to a solar storm ever seen at Mars.
And the orbiters themselves were affected too, right?
They were. Both spacecraft suffered computer errors from the energetic particles, which is a known hazard of space weather. But crucially, both had been designed with radiation-resistant components and error correction systems, so they recovered fast. And the timing was incredibly fortunate. The researchers were able to capture the aftermath of the storm using a technique called radio occultation just 10 minutes after a large solar flare hit Mars.
Radial occultation, for our listeners, that's where one spacecraft beams a radio signal to another at precisely the moment it disappears over the planet's horizon. The signal gets bent by the atmosphere on the way, and scientists can read all sorts of information about the atmospheric layers from the way it bends.
It's a technique that's been used for decades here at Earth, but only recently has it been applied between 2 spacecraft at Mars. This was a perfect demonstration of how powerful it can be.
And there's a broader significance here, isn't there? Mars has no global magnetic field the way Earth does, which is why the storm hit so much harder.
Exactly. On Earth, our magnetic field deflects a lot of the solar particles and channels the rest toward the poles as auroras. Mars lost its magnetic field billions of years ago, and that's almost certainly why it also lost most of its atmosphere and its liquid water over time. This study helps us understand that ongoing process, and it has very practical implications for future crewed missions and radar operations on and around Mars.
Really fascinating stuff.
Okay, story 4, and this one has a bit more of an edge to it.
So this story starts with a SpaceX Falcon 9 upper stage that back in February 2025 failed to execute its planned deorbit burn after delivering 22 Starlink satellites to orbit. It drifted uncontrolled for 18 days before beginning an uncontrolled re-entry about 100 kilometers off the west coast of Ireland.
I remember this one. Some debris came down in Poland, which caused a fairly significant diplomatic incident. Poland dismissed its head of space agency over the lack of communication about where the thing was going to land.
Right. But now there's a new dimension to this story. A paper just published in Communications, Earth, and Environment by Robin Wing and her colleagues at the Leibniz Institute for Atmospheric Physics in Germany has, for the first time ever, directly tied a specific rocket re-entry to a measurable atmospheric pollution plume.
How did they do that?
They were operating a highly sensitive resonance fluorescence LiDAR system in Kühlensborn, Germany, essentially a laser-based atmospheric monitoring instrument. They weren't specifically watching for the rocket, they were just doing their regular atmospheric observations. But right around midnight on the 20th of February 2025, just 20 hours after the Falcon 9 came down, they detected a spike in lithium vapor levels in the upper atmosphere.
Lithium, which is not something that should be up there in any quantity.
Normally, lithium in the upper atmosphere sits at about 3 atoms per cubic centimeter. They measured a spike to 31 atoms per cubic centimeter at an altitude of between 94 and 97 kilometers. That's a 10-fold increase.
And lithium is in the rocket because...
Falcon 9 upper stages carry an estimated 30 kilograms of lithium in lithium-ion batteries and in the aluminum-lithium alloy that makes up the hull plating. Critically, that alloy starts melting at precisely 98.2 kilometers altitude, which matches exactly where the pollution cloud was detected.
That's a pretty compelling fingerprint. But did they need to do more than just say, well, there's lithium up there and a rocket just fell down?
They did. They ran 8,000 simulations of backward wind trajectories from the LiDAR station in Germany all the way back to the re-entry point over Ireland. They checked every other possible source, and everything pointed to the rocket. The case is solid.
So what are the implications? Is a lithium cloud in the upper atmosphere a big deal?
That's actually still an open question, and the researchers are honest about that. We don't yet fully understand the impact on atmospheric chemistry. But what this paper represents is a first. It's the first time a specific re-entry event has been directly linked to a specific pollution plume. And with the growth of mega constellations, hundreds and eventually thousands of satellites being launched and deorbited, this is going to become an increasingly important area of study.
And presumably, we need to start thinking about whether controlled re-entries can be designed to minimize this kind of chemical contamination.
Exactly. That's the question the paper ends with. It's not alarmist, it's more of a we need to start measuring this properly moment, which this paper very much is.
Good. Story 5, slightly lighter.
It's mystery launch time.
Okay, story 5. Rocket Lab launched an Electron rocket from its New Zealand site yesterday evening, local time, marking the company's 83rd launch to date. The mission is called Insight at Speed is a Friend Indeed, which is exactly the kind of cryptic mission name that drives people absolutely mad on the space forums.
What do we know about it?
Almost nothing, which is rather the point. Rocket Lab announced the launch just a few hours before liftoff, which is unusually short notice even for them. They confirmed it's a single satellite for a confidential commercial customer deployed to an orbit about 470 kilometers above Earth. That's it.
The mission name is interesting, though. Insight at Speed. That sounds like it could be an Earth observation or intelligence-related payload. Fast access to imagery, maybe?
That's been the general speculation, yes. Small, fast satellite for rapid imaging. But Rocket Lab isn't saying anything beyond confidential commercial customer. And the customer isn't saying anything either, which is, of course, they're right.
Rocket Lab has carved out quite a niche for exactly this kind of mission. Small, dedicated launches on relatively short notice for customers who want discretion. It's a good business to be in.
83 launches and counting. They're doing just fine. Okay, last story, and I've been looking forward to this one all morning.
That can only mean one thing. It's a food-related story.
Right. Scientists at the University of Texas at Austin, working with Texas A&M, have successfully grown and harvested chickpeas in simulated moon dirt. Published today in Scientific Reports. First time it's ever been done.
Okay, tell me everything.
So the challenge with lunar regolith, which is the technical name for moon dirt, is that it is spectacularly hostile to plant life. It's fine as talcum powder, it's abrasive and clingy, it has no organic material whatsoever, no microbes, and it contains toxic heavy metals like aluminum, copper, and zinc. Previous attempts to grow plants in actual Apollo lunar samples resulted in stressed, stunted plants that absorbed dangerous levels of metals.
So, how did the Texas team crack it?
2 ingredients. First, vermicompost, which is essentially worm castings. Red wiggler earthworms were fed food scraps and cotton waste, the kind of organic material that would naturally accumulate on a long lunar mission anyway, and their output provided a rich, microbially diverse soil amendment that could be mixed with the regolith simulant.
Okay, so worm poo. Got it.
Precisely. Second ingredient, arbuscular mycorrhizal fungi, AMF, which were used to coat the chickpea seeds before planting. These fungi are remarkable. They extend into the soil like a secondary root system, improving nutrient uptake while simultaneously helping to sequester heavy metals away from the plant. They also produce proteins that bind loose regolith particles together, making the stuff behave more like actual soil.
And it worked?
It worked with caveats. Mixtures of up to 75% regolith simulant could successfully produce flowering, seed-bearing plants. Go above 75% and the plants started showing serious stress and dying early. And across the board, the regolith plants produce fewer seeds than the control plants grown in ordinary earth soil. Though the individual seeds that did grow were comparable in size and weight.
Can they eat them?
Not yet. The chickpeas are currently being tested for metal accumulation. They need to make sure no dangerous levels of aluminum or other heavy metals made it into the seeds before anyone takes a bite. The lead researcher, Jessica Atkin, said, and I love this, "Before anyone makes moon hummus, we need to confirm they are safe and nutritious." She has also promised to be the first one to make moon hummus if they pass.
That is a fantastic quote. And I love that she played Bad Moon Rising to encourage the plants in the lab.
She hung a poster of chickpeas growing on the moon above the growth chamber as well. Kind of silly, but something to aim for. This is the energy we want in space science.
So what's the bigger picture here? This isn't just about hummus, I assume.
No, although the hummus angle is doing a lot of heavy lifting for the press coverage. The real significance is this. As we plan for long-term human presence on the moon through the Artemis program and beyond, food sustainability is a genuine challenge. You cannot shuttle all the food you need from Earth to a lunar base indefinitely. The cost is prohibitive. So being able to grow crops from local resources, converting sterile regolith into living soil using biology that future astronauts could actually bring with them and maintain, is a crucial piece of the puzzle.
And chickpeas specifically are a great choice for this, right? High protein, resilient plant?
Exactly. High protein, nitrogen fixing, they actually put nutrients back into the soil as they grow and relatively hardy. The team is now exploring whether seeds from the moon-grown chickpeas can grow a second generation and what the nutritional profile of the harvest looks like. It's early days, but Sarah Santos, the principal investigator, summed it up well. This is a small first step toward growing crops on the moon, but we have shown this is feasible and we are moving in the right direction.
Moon hummus, coming to a lunar outpost near you eventually.
I will be first in line.
And that's your Astronomy Daily for Friday, the 6th of March, 2026. I'm Anna.
And I'm Avery. Thanks so much for listening, space fans. If you enjoyed today's show, please leave us a review wherever you get your podcasts. It genuinely makes a difference.
You can find show notes, our blog, and a whole lot more at astronomydaily.io. And we're at Astro Daily Pod on X, Instagram, TikTok, YouTube, and elsewhere.
We'll be back tomorrow with more of the universe's greatest hits. Until then, keep looking up.
Clear skies, everyone.